No,
No,
I'm here to
just
answer
here for
questions.
support.
Yes.
Moral support. Let me ask you a question in regard to the devices, the ADG devices. I've never gone to visit one. I'm not seeking an invitation, but I'm curious.
We'll offer you one.
I know where solar panels are made, and I know where gazillions of solar panels someday will be maybe made outside of Buffalo. Where are these machines, these ADG machines, made?
So it's probably important to back up a little. So what we do is we collect all the manure on the farm from the cows.
Yeah.
Put them into a big holding vat, heat it to 100 degrees for 21 days, it ferments, and the gas comes off, the biogas, which is 60% methane.
Need a special machine for that?
It's a huge concrete tank.
Make it yourself, right?
No, highly engineered. They're quite complicated. And so then we collect the biogas off of that, put it through engines, and burn it. So because of the nature of it and the gases in it, they're extremely expensive engines and complicated systems. It's actually kind of neat to see.
European technology has been advanced in this area more so than in the United States. So we look to Germany, other EU countries where they've had policy that has incentivized the development and growth and have imported a lot of that technology here.
I think one important thing, so if you back up maybe 10 years ago, anaerobic digesters weren't considered a big source of electricity. At best, maybe you can net meter and break neutral on the farm. 2 or 3 things have happened. The technology and the quantity of gas that we can make per unit of manure has increased. The engines have become larger and a lot more efficient. And then the other thing is the dairy farms have become much more efficient in decreasing our electricity consumption per cow. When you put those 3 together, what's happened is we've become, with an anaerobic digester, still probably a net purchaser of electricity, to now we're a net seller of electricity of maybe, so our farm, we average consumption for the year is about 500 kilowatts, and our production, we're going to be raising it to 1.3 megawatts or 1,300 kilowatts. So we're selling, we're only consuming, 40% of what we can make. And that's why this has become more of an issue, because we've become a true net producer of electricity rather than just a net meter.
So how much does it cost to put in a system, and how much does the interconnection cost?
The larger the system, the lower cost per kilowatt. So I can speak on our behalf. It was 8 years ago we installed it. It was $1,500 per cow, so about $6 million. And that would be for an electric generation of about 1,300 kilowatts. And the other thing, when you were talking about other sources...
How much did the interconnection cost?
We were very lucky. We're in our local utility, which is NYSEG. There's a local guy that's done a good job holding our hand. And so our story is different than others. But we've had... we have probably a better story to tell than most people, so I'm probably not the best person to complain about the utilities, because the utilities have been great to us. So it still took a couple of years, I guess is the long answer. But it was, they ran a special line, probably 4 or 5 miles, a 32.5 line, specifically for our farm to hook, because our generation was causing problems.
So how much did it cost? You.
So it was, we didn't pay for it. We paid for a couple $100,000 or something. It was very little relative to the cost of the line. The line was a couple million.
So you had to buy the land, or
No. It was part of a PSC approval. So the ratepayers paid for it. And in our particular case, which was
so the
highly unusual.
ratepayers paid for the land. You paid
the line.
The line
upgrade.
I see. So you paid about $200,000 for the interconnection.
Yeah, but it was a lot of engineering and.
So in the research that we put together for this statement, we saw the $300,000 is a direct reflection of one example in Western New York. I saw 200, 100, 80,000 investments. It really depends on a case-by-case basis. It depends upon what the grid looks like at the point of location for the digester, what has to be invested. That's going to be a typical scenario as we go forward, and something that ideally we need to simplify and create as much transparency in it so we can understand what's needed.
So what is the issue? The cost doesn't seem, compared to a $6 million cost, a $200,000 interconnection charge doesn't seem like a lot of money to me comparatively. So is the issue something else, or are you very unique? Is the cost usually much higher to put in this kind of generation? Interconnect.
I think it's so variable farm to farm. It depends on whether you have a three-phase line. Some farms don't even have three-phase, so the opportunity to even backfeed in isn't even an option. And I think some of the rules might have changed.
Well, I'm just looking at what the costs are. I get that there are going to be variables, but so what is the range of cost? Compared to the size of the project on a less favorable, where it might be less favorable than you.
So I don't think the cost of the interconnection is the main problem.
It's not the main problem. So is the standby cost?
Well, it's lack of clarity within interconnect, lack of transparency to understand what the costs are going to be.
Upfront. So
right,
lack
up
of
front.
clarity up front, so you don't know when you go into the project.
Some of the other points we made were lack of consistency between farms within a utility as far as the approach that's necessary to complete the interconnect process, albeit they are unique, but there are some common elements within each interconnect process. Recognizing that this is an evolving field, if you will, and Neil and his farmers have been pioneers in this. They were the first ones on the ground or in the ground, and so kind of plowed the ground with regard to, if I can use this farm analogy, with regard to anaerobic digesters. However, you invest $6 million and you invest several $100,000 with interconnect, and then you end up with a recompense system that basically pays you the clearance price for the power that's net metered onto the grid. That's the answer to the rest of your question. It's the price of power that is not credited back for farm use through the net metering system.
I'm not sure I understand. So let's just one step at a time. So the standby charge that they charge you is what is the issue transparency, or the issue the amount of money, or is the issue the concern that you're giving power back, so therefore you don't think that you should be paying anything?
We have no idea what our standby charge is, and we cannot figure it out.
You have no idea.
So lack of transparency in that regard. The net metering by law allows for a credit to the farmer for power consumed at the market price. No problem there. It's the excess or the power that's net metered back to the grid that becomes very confusing. Now, obviously, time of day and issues such as downtime by the generator all factor into the demand charge calculations.
We had no idea. So if the previous testimonies are correct, when we change the oil, we just change it when it's convenient for us. We have no idea that if we shut down at 1 p.m. in the afternoon, it might hurt us more than 5 a.m. or 2 a.m.
Right, so
We had no idea. We learned that earlier.
How many systems are there? You said you're a pioneer. And
There's 28, I think.
Yeah, about 28 total in New York. Potential growth to 100 plus around the state. And as technology continues to evolve, smaller farmers can justify the investment. The other thing to add in is the use of organic substrates as an additional element to feed the digester. So instead of putting organics into the solid landfills, we can transport them into the anaerobic digesters, something that DEC is very interested in and makes a lot of sense for our industry.
I was going to ask what you did with the manure before.
Well, so it does nothing for quantity of manure. One of the biggest benefits is it reduces the odor. So what you're doing is you're fermenting it up front.
What did you do with it before? Before you used it for this purpose.
You land apply it. If I use it for fertilizer for the growing crops.
And there was a cost in doing that, I assume.
There still is the
because
same
you had
exact
storage.
cost. So you still 100 gallons of manure to begin with. We end up with 99.5 or something because a little bit comes off in gas. So it really does nothing for volume, and it actually does absolutely nothing for NP and K, nitrogen, potassium, phosphorus, which is a wonderful thing because we need fertilizer to grow the crops.
So you use it in addition.
Yep.
I see. So there's no. I see.
Yep.
You also, in some cases, you separate the solids from the liquids and use the solids after composting as a bedding element on the farm too. So that is an additional step that can be added into the process.
Is it better manure after it's burned? Better fertilizer or the same?
Yeah, I mean, you still have the same quantity of NP and K. It's a different form. It's a little more bioavailable, but the main benefit to the community is less odor. So the neighbors aren't quite as mad at us for having stinky manure.
Got it.
To put it bluntly.
Thank you so much. I mean, Robert,
Thank you.
Yeah, thank
No,
you. Good.
Yes, I will take a tour.
We'll arrange it.
The next panel is the Combined Heat and Power panel. We have 3 people coming up, I think. Philip Kolaski, who is the Vice President of Engineering and Energy Services for the Durst Organization, joined by Mike Brusick, who is the Senior Engineer for Bright Power, and David Aarons, the Northeast Clean Heat and Power Initiative. So you guys choose.
Great. We would have had you up here sooner, except that Assemblymember Pollen had all those questions about the manure. Let's go.
All right. Good afternoon. My name is Philip Skolaski, and I'm the Vice President of Engineering and Energy Services at the Durst Organization. Thank you for giving me the opportunity to share our experiences with the challenges associated with the installation and economics of combined heat and power systems. First, I would like to provide a brief overview of the Durst Organization's experience with sustainable buildings. Durst Organization celebrated its 100th anniversary last year, and we are one of New York City's largest developers and owners with more than 13 million square feet of Class A Manhattan office space, nearly 5,000 residential rental units built, under construction, or in the development pipeline. The Durst family has been at the vanguard of sustainable construction and building operations for 25 years. We have a number of notable firsts. One Bryant Park, the first LEED Platinum skyscraper. One World Trade Center, the largest building designed to achieve LEED Gold certification in the United States. 4 Times Square, the world's first green skyscraper. 1155 Avenue of the Americas, the first thermal ice storage system in New York City. The Helena, New York's first voluntary LEED certified residential building to receive gold ratings, and Manhattan's first building-wide residential composting program. Over the course of building close to 10 million square feet of sustainable buildings, we have piloted many on-site energy technologies, including solar, geothermal, heat recovery, fuel cells, and cogeneration. In 2004, while OBP was in the initial design stages, it was conceived that we would install on-site cogeneration. While the fuel cells at 4 Times Square did not perform as we had hoped, maintenance costs made them prohibitively expensive, we very much liked the concept of generating on-site power. We designed into One Bryant Park a 4.6 megawatt combined heat and power plant. It runs on high-pressure natural gas and uses the waste heat to generate steam to heat the building in the winter, and through an absorption chiller, make chilled water for air conditioning in the summer. The power from conventional utility power plants is about 45% efficient, while our cogen plant approaches 70% efficiency. Our cogen provides more than 2/3 of the building's energy and produces half the carbon of a conventional power plant. The plant required a steep capital investment, close to $30 million, but performs brilliantly. The primary challenge for OBP cogen, for One Bryant Park's cogen, is the Con Edison charges. The Durst Organization is paying $1.1 million per year, including taxes, in steam standby charges alone. This is based on a 39 M-pound contract demand. This charge is solely to have the ability to use Con Ed steam if the cogen shuts down. There are other significant charges if we actually have to use Con Edison steam. $1.1 million annually before we use 1 ounce of steam is punitive at best. The Con Edison steam system, the Con Edison steam standby charges are so high that we have studied the installation of natural gas-fired boilers to back up the cogen plant, which would cost approximately $6 million and would pay back in less than 6 years. Not a bad deal for a system that we would only use 5% of the time during planned outages. Over the last several years, the plant has sustained minimal unplanned outages. These standby charges make cogeneration plans cost prohibitive and rob the city of clean, reliable, and environmentally responsible means of energy production. One way to fix this problem would be to provide standby performance credit similar to the mechanism in place for the electric standby charges. if there are no outages on the steam system peak days over the course of the year. This solution would mitigate the cost of steam standby while ensuring that Con Ed recoups costs associated with maintaining distribution systems for peak days. Another option would be to reduce the annual $1.1 million fixed charge. There have been some changes in the past year that have helped to improve the economics of electric standby tariffs. The methodology for how specific charges are billed to the customer is now based on net energy usage at the site rather than the gross. In addition, an electric standby performance credit was enacted for the summer of 2015, which allowed customers to reduce its contract demand by the minimum power produced by the cogen facility as long as the facility had no more than 3 interruptions throughout the peak summer period. One Bryant Park Cogen was able to attain such a credit. Although the electric standby tariff has improved, the basic rate design is flawed. Like the steam standby tariff, there is a charge that you have to pay regardless of whether you use any Con Edison electricity. CHP, along with other distributed generation, supports the goals of the Reforming Energy Vision proceedings, of which one of the key goals is to encourage locally installed generation. The current tariff is a significant barrier to private development of cogeneration facilities. Besides the large capital cost, such facilities have major operations and maintenance costs that are not offset by the revenue generated from the power and thermal energy produced. We've heard the term revenue neutral, which is defined by the Public Service Commission as the full service class, not any individual customer, would contribute the same revenues if the full class were priced under either the standard service class rates or the standby service rates. Blind adherence to this principle has prevented any analysis of the fairness of the standby rates, and its implementation does not allow for customers in other service classifications, for example, small commercial customers, to help financially support the resiliency that distributed generation is providing to the grid. Other challenges include the difficulty and cost associated with Con Edison's interconnect requirements. One onerous requirement to interconnect to Con Edison's grid is the installation of direct transfer trip systems. This system is required by Con Ed to remotely monitor or trip the system offline under certain conditions. It requires the installation of data equipment consisting of 2 identical racks, one installed at the Con Ed substation, one installed at the cogeneration facility. The upfront cost for such equipment to support the One Bryant Park Cogen was approximately $500,000. Further, Con Edison charged us approximately $300,000, consisting of both material and labor, to make upgrades at the substation to accept the connection of this transfer trip equipment. Beyond the upfront capital cost, the standby tariff requires that we pay an additional 12.1% of that cost, of the cost to interconnect, as an annual maintenance charge to Con Ed, which equates to approximately $42,000 per year, including taxes. Why are we paying a maintenance fee on costs that was primarily labor in perpetuity? We're not sure. The transfer trip system also requires redundant point-to-point T1 data lines, which are provided by Verizon at a cost of $8,500 per year. Although a small cost, this is another cost to support a system that is antiquated and somewhat redundant to the electrical protective relaying already in place. In addition, regulators are often unprepared to assess new technologies like cogen, and permitting can be onerous, especially with high-pressure gas. The interconnection process with the local utility only further burdens the installation of such systems. Of all the sustainable technologies we have installed in our buildings, we are most enthusiastic about cogeneration, but it requires the assistance of government and regulators to proliferate. The Durst organization is committed to improving the environment by continuing to build sustainable buildings as well as future on-site generation. However, the tariffs must be improved to better incentivize this cause. Thank you for allowing me to share some of our experiences with you.
So we'll finish the panel and then we'll ask questions. Yeah.
Good afternoon, I guess it is. Okay. So, hi, my name is David Aarons. I'm on the board of the NECHP, the Northeast Clean Heat and Power Initiative. I'm filling in for Herb Dwyer, who couldn't make it today. And I just wanted to enter into the record the mission statement in regards to NECHP, which I've provided to you, and also invite you to one of our members and a client of mine, Co-op City. Co-op City has installed a 40-megawatt cogeneration plant in the Bronx. Co-op City serves 55,000 people and is the largest affordable housing development in New York State, and we think probably in the United States. It is also the largest residential microgrid in the state and has 38 megawatts, as being the second largest microgrid throughout the state. In addition to its 35 high-rise buildings and 7 clusters of townhouses, the Co-op City microgrid also serves schools, a firehouse, a police house, and commercial facilities within its boundaries. Over the years, Co-op City has tried to participate in different programs, and it also has concern about standby rates, as Phil illustrated. But Co-op City also tries to participate in the wholesale market, and we'd like to explore that with you today to reduce barriers to participate in the wholesale market as well. I'll take any questions. Thanks.
Hi, good afternoon. My name is Mike Brusick, and I'm here on behalf of Bright Power. We're an energy management and consulting firm. We focus on providing services to the multifamily real estate sector nationally, but with a particularly strong focus downstate here in New York. This is where we originate from. We've acted as consultants, owners' representatives, designers and installers of solar photovoltaic and cogeneration systems in New York City. We installed a few of the solar photovoltaic systems in East New York that were referenced earlier. And we'd like to address the issues of standby rates and net metering as they've impacted some of our clients for cogeneration systems. The bulk of our work has been in Con Edison territory, so some of our comments may be particular to there, but they're also relevant in other utilities with similar standby rate structures. We generally agree with the concerns raised that standby rates can be punitive, and in some cases, it's unclear whether they are in fact cost neutral to the customers. But the thing that concerns us more are some additional impacts that they can have because of complexity and lack of transparency. The complexity of these rates and the risk that entails means that prudent owners and developers will almost always engage a consultant to evaluate what the cost impact of switching rates will be as part of developing a cogeneration system project. In some cases, that analysis is also either recommended or required by incentive programs for the cogeneration system. In Con Edison territory, there is a standby rate exemption, which has been mentioned, but it does require that for small-scale cogeneration systems that they exceed a certain overall efficiency. And that's an additional analysis that has to be performed to determine whether or not this system will, in fact, have to go onto a standby rate. The cost of acquiring the data necessary for that analysis and performing it can add significant overhead, especially to smaller cogeneration systems, particularly in the 1 and 200 kilowatt size, which, as we heard earlier, are one of the fastest growing segments of CHP being installed. The result is that standby rates, because of their complexity and because of a lack of transparency, actually have a chilling effect on the development of all cogeneration systems, even ones that don't ultimately end up on that standby rate. It's also worth mentioning that the standby rate exemption requires a certain overall efficiency, and that acknowledges that it's in the public's interest to install efficient cogeneration systems that don't simply dump their waste heat, but actually utilize both the thermal and the electrical energy produced. But that's actually exactly the opposite of the behavior that the standby rate structure incentivizes. People who have to pay contract demand charges and have to pay surcharges if they exceed their contract demand are incentivized to run the system flat out and maximize the electrical output of it, regardless of whether or not they are capturing waste heat from that system. And we have seen several instances where, both because of the economic motivations and just sort of overall fear of penalty charges, the systems were being operated in a fashion that was less efficient than possible. One policy solution to this would be to require that utilities provide a calculation tool to compare existing and potential standby rates, similar to how some utilities provide a tool to compare supply charges as provided by the utility or as provided by a third-party ESCO. Such a tool would take a series of hourly electric loads and would output what the monthly electric costs would be for the customer's existing rate and for standby rate. And that would greatly facilitate the kind of economic analysis and lower the cost of doing the kind of economic analysis that's necessary to do these systems. That is a task that needs to be undertaken by the utility. Because there's so much complexity in how these rates are calculated, and because there are very few consultants, even if they were fully armed with knowledge about the tariff, there are few consultants that would be willing to take on the liability of second-guessing utility rate engineering departments. That's a tool that would have to come directly from the utility, but we think would really lower some of the barriers without changing the existing standby rate structure at all, would lower the barriers and help customers make better investment decisions in cogen systems. Turning to the subject of net metering, as has been mentioned before, in large commercial and multifamily facilities, net metering of cogeneration systems is not currently allowed. And to allow it to do so, to allow it to net meter, and particularly to allow it to remote net meter, could unlock significant value both to customers and to utilities, which we feel isn't being realized right now. And the benefits really, as we see them, arise chiefly in three areas. The first one being resiliency. Many of the buildings that we work with, the largest percentage of the multifamily buildings that we work with, are direct metered, which means that residents have their individual Con Edison meters, and there's only one meter for relatively small common area electric loads. There's also very variable electric loads. And so often the cogeneration system, because it can't net meter, needs to be sized smaller than it otherwise could be if it was allowed to export power some of the time. And that misses out on an economic opportunity, but almost more importantly, misses out on an opportunity for resiliency, because with increased system sizing, there's the possibility of powering more critical loads at a facility. Without net metering, they may not have been able to install a system large enough to meet all of their critical loads. There's also an opportunity for increased demand response capability. Where these systems are constrained by the electric loads of the building, they can't participate in demand response even if their nameplate capacity exceeds what the current load in the facility is. And so because the cogenerator can't reduce its output, or can't increase its output below what the minimum power import set by the utility is, it's unable to provide capacity that could be used for demand response, even though that capacity exists and is a resource. And lastly, the ability to net meter and remote net meter, we think would remove barriers to installing cogeneration at many large housing developments, many of which are often served by a central plant for heat, but have completely separate and discrete electric services throughout the housing development. And a central plant provides a prime opportunity for utilizing the waste heat from a cogeneration system, but there may be relatively small electric loads attached to that plant. And so allowing the plant to net meter and to remote net meter to other buildings in that development would unlock significant opportunities particularly in many of these which are affordable housing developments and have very tight operating budgets. And so allowing remote net metering would facilitate the installation of cogeneration systems in buildings that really need those operational savings and need that resiliency most, and would contribute to the preservation of New York State's affordable housing stock. One form of that net metering is already available in Con Edison's current tariff, but it does require that all of the participating buildings be transitioned to standby rates, which, as we've talked about earlier, is risky and potentially increases the cost to the customer in a way that can make these projects less economic. So we feel that legislative changes to standby rates and to net metering could really provide a number of opportunities that would increase the deployment of cogeneration and provide previously unrealized value to the public. Thanks for giving us the opportunity to speak here.
Yeah, could I just begin, because I come from Buffalo, and I don't believe in Buffalo we have steam pipes running under the streets that send steam into buildings. And so when I heard the testimony from Mr. Skolasky about steam coming from Con Edison into your building, my ears perked up, because we don't do that in Buffalo. We also don't have cows in the street in Buffalo. So educate me, please, as to what it is that Con Ed sends into your building. It sends steam into your building. How nice of them. Yeah. Is this in Manhattan
For a huge
only?
cost.
At a huge cost. This is only in Manhattan?
It's mainly Manhattan. It's mainly Manhattan.
Okay,
And it
and-
stops at some central, yeah.
And there are many buildings into which Con Ed sends steam?
Most of our large commercial buildings have steam to them. Some of our larger commercial buildings, one of which is 1133, which is just north of One Bryant Park, we just converted that from steam to gas-fired condensing boilers, and it's a payback in, again, less than 6 years. Just forget about standby tariffs, just on usage of steam, because steam could be, in winter months, upwards of $42 per 100,000 BTUs or per M-pound. So it's very expensive to buy from Con Ed, whereas we can supply some capital cost, put in our own boilers, and buy the same amount of gas for $10 for that same amount of energy, and make our own. So there is a quick payback, but again, it's typically the cheapest upfront cost to use steam from Con Ed. So a lot of times, a lot of developers will use steam if it's right there and it comes from Con Ed. There's just an ongoing charge with it. You're paying for it. You're paying not only for the steam, but you're paying for the process for Con Ed to make that steam, and it's expensive.
Steam makes your electricity?
No, the steam is used to heat the building.
The heat.
It's
okay.
primarily heat and hot water. That's what we
I
use
see.
steam.
They make this. You make the steam.
So with
to
our
generate
cogen
your
plant, we make 100% of that steam. So our cogen plant makes about, just based on the waste heat alone, makes about 12,000 pounds an hour of steam. Our building, worst case peak, runs at about 30. We have a 39 M-pound contract demand with Con Ed. That's because we don't want to overshoot it if we ever had to use it on the worst case day. But we run at about 34,000 pounds an hour on like a 0-degree worst case day. The cogen plant can make up to 50,000 pounds by itself. So just on the heat rejection alone from the cogen plant, we make about 12,000 pounds. And then we have what's called a duct burner that will inject gas after the waste heat comes out of the generator, and it injects gas, and it'll fire up that boiler to up to 50,000 pounds an hour. So we support the entire building.
So the performance credit that they're projecting is good for the electricity doesn't apply here.
Correct. There is no performance credit for steam
I see.
yet. We're hoping there's something with that, and also these charges are just obscene.
I mean, is that something that, it wasn't a question I knew to ask, So is it something that's being discussed that you know about?
proposed it. There have been separate meetings with REBNY and the Public Service Commission, as Mrs. Abelman said before, but
Right.
we don't feel like we've gotten anywhere with.
Well, it just
you
seems
know,
that
with
CHP, if it's mostly in the city, and the city doesn't do much else, right? And that's the clean source that we're hoping for. And most commercial buildings use steam, then it seems to me you need to address it.
Absolutely. Absolutely. We've had separate meetings with Con Ed Steam Division, with Public Service Commission, but nothing has come out of it yet.
Now, would that solve your problem?
I think that would solve a lot of the problem. Again, the electric tariffs have gotten better. I don't think they're where they need to be to fully incentivize. To give you a high-level approach, we paid almost $30 million for the plant. Based on the cost of gas, we have to pay for gas. We have to pay these standby charges for electric. We have to pay for the standby charges on the steam system. We only make about $1 million a year. Well, before they made these changes in June, we made about $1 million a year profit, which is a 27-year payback. That's terrible. That's longer than the equipment lasts. The equipment has to be rebuilt every so many years. There's a lot of costs that go into these pieces of equipment, not to mention the people to run it. It's a 24-hour, 7-day-a-week operation. So 27-year payback is terrible. Now, they made some of these concessions. We've gotten approximately $300,000 savings on the contract demand incentive that we attained this past summer. And I think the changes that they made in the tariff gave us another about $400,000, $500,000 a year worth of savings. So $800,000, it's better. It's down to 15 or 16 or 17-year payback. It's not the 6 to 10-year payback that somebody would expect on a large investment like this. Mm-hmm. We've also looked at 4 Times Square. We have an opportunity to do some large cogeneration there. And for the past 2 years, we've been studying different scenarios. We studied 13 different scenarios for that building, anywhere from a 2.4 megawatt plant all the way up to a 13 megawatt plant. Capital investment of like $12 to $15 million for the smaller plant, all the way upwards of $65 million. And none of them work. We can't get them to work on paper with the current tariffs. They're upwards of 20, 30-year payback periods. It's not of value to us.
It seems to me that would be a huge project and would be of benefit to the system. Is when that happens, is there a dialogue? Yeah.
So we did have dialogue. This is part of the, again, REBNY, REV, and the Public Service Commission came in. We submitted those 13 studies as
information.
It was they were test cases. They wanted to see what we were doing. We made a presentation. Ourselves related, other major developers in the city have made presentations, JLL, about different size systems that were all on the table and nobody could get it to work. They were all in the queue, but nobody could get it to work economically on paper. And so why invest the money? It's got to work for the business case. We want to be clean. We want to help the environment, but at the end of the day, it can't be a loser for us. We can't be wasting money on this. It's got to be for a reason. So, and we're not looking for great returns. Again, we will consider it if it's 10 or 12 or somewhere around their payback, but 15, 16, 17, 20-year paybacks, it's not worth it.
Got it.
Does this steam that gets produced by Con Ed, does that aspect of Con Ed's operation fall under the State Public Service Commission, or is it?
I believe so,
subject
yes.
to some other entity?
No, it does.
Yes,
I know
it
that
does.
because Westchester's always trying to fight the steam piece
Charges,
not
correct.
going into their rates,
Yeah,
right?
that's
So, living up there, I'm familiar with that, but I never understood it really. So, thank you. I just want to address the net metering issue. When you produce extra power to the grid now and you're connected, do you get avoided cost credit?
Right now, you don't get anything because for multifamily and commercial buildings, you are not required, or you're not allowed, you're not permitted to export power, except for in some cases with larger systems. But
Co-op City is a larger
Yeah.
system connecting at a high tension. So they do export power into the grid, and they receive what's called the LBMP price,
Right.
the New York ISO market price on the market for that.
Right, which
for that
includes
energy.
you have to pay the distribution cost within that. But that's not the case for smaller units?
But most of, perhaps not in terms of capacity, but certainly in terms of number of applications, most of the development that's happening with CHP in New York City right now is smaller systems, which are not generally permitted, or it's not economic for them to connect in that way and export power. So they're required to, in many cases, if they're constrained by the electric load, even just for certain hours of the day, they're required to ramp down their production instead of exporting that power. That also adds capital cost to the system
Now,
because
is
they
it-
have to.
I guess I'm confused between, are they capable of doing it? Or, another,
They're
like what happens
technologically.
if you didn't rev it down? What happens to the power?
Well, they're technologically capable, but when these systems are installed, one of the common requirements is protective relaying that prevents them from exporting power.